Hello, everybody. So today we're starting in on the next chapter, and actually to this point we have learned basically all the skills we need, all the different measures, probability, everything that we've learned is leading us to the next two subjects. And the first one we're going to look at in this chapter is confidence intervals. So confidence intervals are something that we do definitely use. We might personally not use them in their very formal state, but people do use confidence intervals. So now that we're at the end of the semester, we're getting into like, how does this actually get used on an everyday basis? So confidence intervals is where we're going to start. Now, like I said, this gets used. It might not get used formally, but we pretty much have all either seen this or used confidence intervals before. So let's say that you were going to go over to somebody, you're going to go meet somebody for lunch. And so you say, okay, I'll be there in about an hour, give or take 10 minutes. So what you've just done there is you have given a confidence interval. So what you've said to this person is that you think it's going to take you an hour to get there, but you also know that probably isn't going to be exactly an hour. It's probably going to be a little bit before, a little bit after. So you say, it should take me an hour, give or take 10 minutes. And kind of what you've done is given yourself a little buffer zone so that if you get there in an hour and 5 minutes, the person won't be upset. If you get there in an hour and 30 minutes, they're going to be like, wait a minute, you said an hour, what the heck? And you can change that buffer zone as you feel. Like, let's say that you needed to make a long trip, a number of hours. You might say something like, let's see, I'll be there in about 4 hours, give or take 45 minutes, or give or take half an hour. Because you know that if you have to travel this longer distance, that maybe there's more of a chance that you have to stop and go to the bathroom, or you run into traffic, or any sort of different things. Maybe you hit every single stoplight green and you actually get there earlier. So that's why that give or take that is both below or above. So again, you say to your friend, I'll be there in an hour, give or take 10 minutes. If you hit every stoplight green, woohoo, you might be there a little bit early. So that is a confidence interval. Now in statistics, we use confidence intervals in exactly the same way. We just make them a bit more formal using the different measures that we've learned and the different probability techniques that we have learned. But all in all, it's the same thing. It just looks a little bit fancier. Okay, so I want you to keep that in the back of your mind, is that when we're doing this, this is something that you've seen, this little give or take. You've done this before in your life. When you go to the store to buy something, you think, oh, you know what, that's going to cost me about $20, maybe give or take $1 or $2. And you might not actually say it out loud, but you are thinking that way because that's a common way for people to think. Like I said, now we're just going to see it formally done. Okay, so we say, when we look, when we want a population parameter. So let's say we're interested in the population mean. So we're interested in mu. But we don't have it. Okay, we've learned to this point that a lot of times you don't have all of the population, but we don't have it. What are we going to do? Well, we're going to use an estimate, or we make an estimate. And we have learned at this point that we don't just guess a number out of thin air. If we don't have the population, we take a sample instead. So that's what we're kind of getting to right here. Now, this guess or this estimate that we're going to make has a very particular name. This is called the point estimate. Okay, and the point estimate is any guess at a population parameter. But remember what I just said, we don't just guess out of thin air. We say the best point estimate is a sample statistic. So if we don't have the population, we go to the sample. So again, if we are looking for, if we want mu, okay, we're interested in the population mean, we're going to use X bar. If we want the population proportion, so if we want P and we don't have P, then we're going to use P hat. Okay, so this point estimate is basically something we've already done. It's just finding our sample statistic. We've done that. We've already learned how to do that. Okay, so then we say a confidence interval is an interval centered around a point estimate, hopefully containing the population parameter. So we're going to make this little interval around our point estimate or our best guess. And the interval, we are definitely hoping that we actually catch the population parameter in that interval. So again, the idea is if you say to your friend, I'll be there in an hour, give or take 10 minutes. Well, the whole reason for doing that is that you're really hoping that you get there between 50 and an hour and 10 minutes, right? 10 minutes before to 10 minutes after. You wouldn't give that interval if you're like, I don't know when I'll get there. I'll see you later, you know? So you're giving that interval because you're hoping that you'll actually get there during that time, okay? Now, again, as we said, we're being a little bit more formal here. So this idea of hopefully doesn't quite cut it for us. So we got one more definition here, and that's called the level of confidence. And the level of confidence is the probability our actual, that's not how you spell actual, our interval actually contains population parameter. So as well as giving this interval, okay, we're also going to give what we call a level of confidence. And our level of confidence is going to be very formal. But again, let's take our just basic example here. So we all have friends, know people that if they say that they're going to be there in an hour, give or take 10 minutes, you know that they're going to be there in that interval, right? They're reliable. You have a lot of confidence in them, okay? So their level of confidence is high. But we also all know people that when they say, oh, I'll be there in an hour, give or take 10 minutes, you're like, yeah. I'll see you next week. You know, they're not as confident, they're not as reliable. So their level of confidence is much lower. So, and again, we're going to do it in a formal sense, but every day when you hear people talk to you and tell you things, you're attaching that level of confidence as to who do you trust and who don't you trust. So, but because in statistics, we don't know who to trust and we want to be very ethical, we'll let the math do it for us. And that's why we've practiced for the last 3 months doing all the stuff we've been doing, okay? Okay, so a confidence interval has a level of confidence and it's centered around this point estimate. So I'm gonna write the formula up here for a confidence interval, and it's gonna look horrible. It comes in different forms. This is just always the form I've always used. But after you write it down and we talk about it, I think you're gonna realize it's really not that bad. This is really not a horrible section to look at. Okay, but here is, we're gonna do confidence intervals, and we're gonna focus on the mean to start with, for mean, and we're gonna focus on a large sample. Large sample means greater than 30 so that we can assume that everything is normal, and this is the formula. Now, as I said, write it down and we'll talk about it. So the formula starts like this. It says x squared minus z sub alpha over 2. And the little alpha looks like the little fishy. Okay, alpha is that little fishy. Times sigma over the square root of n is less than mu, which is less than x bar plus z sub alpha over 2 times sigma over the square root of n. I know, no, it's the ugliest thing we've seen so far. But as you really start to look at it, writing it down, all of a sudden you're going to notice some things about it. So as you write it down, notice that it is an inequality because we're making an interval. We're going to have a low end and a high end. So that's what the inequality sign is for. And we're hoping that the actual answer is in our interval. So that's what the mu is doing in the middle there. Now look at either side. Now that we look at either side, do you notice how they're almost exactly the same? The only difference is this side has a minus and that side has a plus. Okay, so remember, I'm gonna be there in an hour, give or take 10 minutes. Plus 10 minutes or minus 10 minutes. So they're basically the same thing on either side, just a plus or a minus. Okay? Now, most of these variables we are familiar with. X bar, z, sigma, n, mu. We've done all of these variables. The only thing that's new is this alpha over 2. And that alpha over 2 is where we're looking at our confidence. So it's just a z-score, but the z sub alpha over 2 will represent our level of confidence. So z sub alpha over 2 represents confidence level. And once we learn how to find that, you'll see it's really not that bad. It's just a new notation, but it's really not that bad. Now, one other thing though that I want to make a note of before we move on here is that the part that's the same on both sides is this part. Okay, so this is this give or take, or this plus or minus, okay? And it will always be the same on both sides, and it has a name. This is called the margin of error, or sometimes just a big capital E, which I know is kind of repeating variables that we've seen before, but the margin of error, or just the E. Okay. Alrighty, and so if it's something asks you to find the margin of error, it's not asking for the whole thing, it's just asking for that part. But even in that part, we need that z sub alpha over 2. So let's go ahead and look at this. Let's look at an example. Let's say that I wanted you to be 90% confident. So when you give somebody an interval, be there an hour, give or take 10 minutes, I want you to be 90% confident, which means that there's a 90% probability that you will be there in that time interval, okay, 90%. I'm not giving you all the extra numbers or anything like that. We're just gonna focus on our z-score here. So because we're dealing with a large sample, it is a z-score, and so I'm going to draw a graph. And your point estimate is gonna fall in the middle, okay, so there's your point estimate always. And we are making this so that our interval is centered around the point estimate. So we can do anything we want. So what we're doing is making sure that it's symmetrical. Okay? It would sound weird if you said to somebody, I'll be there in an hour, give 2 minutes and take 15 minutes. That seems weird. So when you do the give or take, you always center it over the point estimate. Now, the part that's shaded in here is our confidence level. So this 90%, or in our case 0.90 if we're looking in decimal form, is represented here. Okay. Now, in order to work the math here, we don't need the whole thing, we only need one half or the other, and this half happens to be the easier one. So if this whole thing is 0.90, how much is just this one side of shaded part? And wouldn't that be 0.45? If you divide 0.90 by 2, do you get 0.45? So now is the little alpha over 2 starting to make sense? It's basically telling you what to do. It says take 90 divided by 2, 45. Boop. Sound good? Now, what we're going to do is find this z-score. But in order to do that, we actually need to know, not the 0.45, but if we think about using our calculator, we actually need to know this area out here, this part over here. So we have to think of some complements here. If this is 0.45, wouldn't this be 0.05 so that the whole side makes 0.5 or 1/2? Okay, so in order to do this in your calculator, remember we always need a left tail. And this one, we're not going to use the normal CDF, we're going to use the inverse norm because I've given you an area and I want you to go back and give me a z-score. So we're going to do inverse norm. And remember when you do inverse norm, you're always plugging in, always, a left tail. So we don't want this area, we want this area. So we're going to put in 0.05. Okey-dokey. And then since it's been a while, we will go find this. So if you look at your calculator, remember you're going to go second distribution. Inverse norm is the third guy down. Boop. This time I want an area of 0.05. And remember, if your calculator doesn't give you this screen, you just put in 0.05 and hit enter. Enter. And it gives you negative 1.6448. Okay, now we've got a little bit of an issue here. Negative 1.6448, blah, 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 blah. Okay. Should round to negative 1.64, yes? But in all honesty, as calculators get more advanced and things get more advanced, these decimal places get more advanced as well. But back when statisticians first started looking at a 90% confidence, they didn't know that it was negative 1.64. They thought it was 1.65. So even though this is what your calculator spits out, for this one example, we use negative 1.65. Sorry, I'm gonna have to take a break. A bird just flew by. Okay, I'll be back in a minute.